Hey guys, we are going to be moving on to 6.5, transformations of exponential functions. Okay, so I'm going to be popping back and forth between this camera view and the calculator, okay, to better explain this. All right, so transformations, okay, as we've talked about before, all right, transformations is essentially and very basically to move around the graph. Okay, the graph of a specific equation. Okay, okay, and so we are going to be talking specifically about translations. All right, when you think of translations, you want to think of sliding the graph either up or down. Okay, when we talk about up or down, we're talking about vertical translations. Okay, and the other possibility is left or right. Okay, when we talk about left or right translations, we're talking about horizontal translations. Okay, so just sliding it, taking it, it's going to look exactly the same. Okay, it's going to look exactly the same, right? We know what our exponential shape kind of looks like here. It's taking that and just maybe giving it a horizontal transformation over, or translation over here, or we could be translating it vertically up. Okay, so they all look the same. This is the same as that, is the same as that. It's just in a different location. Okay, so another way to think of a translation is if I had a box here and I just slid it over to the right. The same box-ish. Okay, it's a little bit bigger, but imagine it was the same size. I just slid it to the right. Okay, same size, same shape. Okay, so we're going to talk about when you might notice it's horizontal and when you might notice it's vertical. Okay, so let's talk about vertical translations. Okay, as we saw in absolute value functions, we could move the graph around as well. Okay, so we're talking about vertical translations. Again, we're talking about either up or down, sliding it either up or down. Okay, we have kind of this formula here. And we'll use a number with this one just as an example. Okay, so you might look at that, you say, Mr. I, there's a number missing for that absolute value, or for that exponential. And we do know that it's a times b to the x, okay? And you can see that we only have b to the x here, okay? Whenever that happens, that means that a is equal to 1, because 1 times anything is itself, so they just don't write the 1 times. So in case you're wondering where that number in front is, it just means that your a equals 1, okay? So 2 to the x power, okay? X is our exponent, and we are going to have something like, I don't know why I wrote a number, plus k, okay? And just for clarity, I'll rewrite it as 2 to the x plus k. So what we're going to be doing, it's a plus, but it could be a minus, okay? It could be a minus. All right, so you go from having f of x equals 2 to the x plus k, okay? And you, or 2 to the x, and you add or subtract something in the base, okay? So it's still one of the big numbers down here. It's not doing anything to the exponent, okay? So, okay, so you can see f of x equals 2 to the x. Here is our table. with some points, okay? And we know that, so we talked about the asymptote. The asymptote is at y equals 0, okay? So it's going to approach y equals 0, but never actually touch it. It just keeps getting infinitely smaller, okay? All right, so that's f of x equals 2 to the x on its own. All right? So, okay, so let's see what it looks like when we add in f of x equals 2 to the x plus 3, okay? So again, we're talking about vertical translations here, so we're going to add 3 here down in the big number part, not in the exponent, okay? So you can see that when we plug in 0 before f of x equals 1, because 2 to the 0 equals 1, 2 to the 1 equals 2, 2 to the 2 equals 4. Now, 2 to the 0 power equals 1, but now we're adding 3 to it. So 1 plus 3 equals 4. 2 to the 1 power here equals 2, and 2 plus 3 equals 5. 2 to the second is 4, 4 plus 3 equals 7. So what that does graphically, right, you can see we went from 1 to 4, 2 to 5, 4 to 7, 8 to 11. So everything's 3 bigger. So everything is up 3 points straight up, okay? And now this asymptote is no longer at y equals 0. It's now at y equals 3. Right, so it's approaching this y equals 3 line, okay? It'll never touch it. It'll never go below that, all right? Okay, so one other thing, so what we can say is that this arrow means it's going to go on forever to the left. This arrow means it's going to go on forever, not only up, but kind of off to the right, okay? So what we can say is, if you'll remember, we talked about domain as being x values and range as being y values. Okay? So for our red line, our domain is going to be all real x values. Okay? Because it's going to get to all negatives, all positive. The range for y values, talking about up and down, it's going to be y is greater than 0. Okay? Because it's never going to actually touch that line. It's just going to be greater than y equals 0. Okay, and when we look at the pink line up here, the domain again is going to be all real numbers, right? X values go left and right, go on forever this way, go on forever to the right. All right, but it's going to, for the y values, it's going to stop here and only go up. Okay, so for our domain again, for the pink line, all real numbers. And for our range, okay, if it's going to approach this line right here, 1, 2, 3, that's y equals 3. So y is greater than 3 because it's never going to actually touch that y equals 3 line. It's just going to be greater all the time. Okay, so domain and range there. But the main point is that this plus 3, okay, down here is going to move it up 3. Okay, so if I said 2 to the x versus 2 to the x minus 4, okay, what we'd be looking for is that this is a translation 4 units down. Okay, so what you need to memorize is that when the plus or minus happens down here with the base, that is vertical. Plus means up, minus means down. Plus means up, minus means down. When you are adding this big one down, the big number down here. Okay? Okay. Now when we talk about our horizontal translations, we are going to add or subtract up here in the exponent. Okay? So we might have, again, our f of x equals 2x, which we've already graphed, or 2 to the x. Okay? We've already taken care of it, the red one here. Okay? And we'll do this one on the calculator. All right? So we're going to compare it to f of x equals 2 to the x minus 4. Okay? So I want you to think about what that might look like. Okay, you remember we had some interesting rules last time when we talked about absolute value functions. So 2 to the x minus 4. Think about what that might look like for a second while we bring up the calculator. Okay, so we're going to add a new, no, we don't want that, add graphs. So we'll put in our basic 2 to the x. Okay, there it is. You know, this showed you in class the other day. If you want to see what those values look like, you can do a split screen table. Okay, so when you plug in, so here's the x value. Plug in x0 for x and the 2 to the x. The f1 of x or the y equals 1. You plug in 1, you get 2. When you plug in 2, you get 4, 3, 8, etc. Okay. So when we go back to menu, we can go to the table and remove the table. Okay. So we are going to look at what happens when we make an adjustment up here and we do x and we said minus 4. What is that going to do? Okay. Well, it can be difficult to tell here. You might say, well, maybe it's still moving it up, but not quite. Okay. So what we want to do here is we'll look at our tables here. So we got our basic one there. We got 2 to the x. So here's 2 to the x minus 4. If you hit to the right, see 2 to the x minus 4. Okay. So we can see that we don't actually get to 1 until we plug in 4 for x. Okay. We don't actually get to 1 until we plug in 4 for x. So what this is doing is it's actually sliding everything to the right. So over here, when x was 0, y was 1. Over here, when x is 0, it's only 0.063. It's all the way till 4, x equals 4, that y equals 1. So over 1, 2, 3, 4, now we're up here at 1. So 0, 1, 4, 1. Okay, so what that did is we went from 0 to 4, so that means everything is slid 4 to the right. Slid everything 4 to the right. All right. And so while we're here, we'll just type and we'll add in 2 to the x plus 3. So if we had minus 4 and it slid it 4 to the right, plus 3 should slide it 3 to the left. Okay? Translation, just moving it left and right. All right, so horizontal translation moves it left and right. Okay. So in this horizontal translation, x minus h, all right? So when we subtract from the exponent, we move that many spaces right. Okay, so you would think that it would go left, but when we subtract, it means move right. So this meant 4 spots right. Okay. Conversely, when we add to the exponent, we move that many spaces left. Okay, so if we had f of x equals 2 to the x plus 3 like we had in the calculator, okay, that means we're moving 3 translated 3 spaces left. Okay, so again, this is one of those things that we talk about. Yes, it's math, but you have to do some memorizing. You have to memorize that when you add or subtract, add to the exponent, you're moving to the left. When you subtract from the exponent, you're moving right. Okay? When we talk about those vertical translations, When you add to the base, you move up. When you subtract from the base, you move down. Okay? So again, it comes down to memorizing, guys, memorizing. And that's where we're going to stop for this video. We will kind of review it a little bit in class on Monday or next week, depending on your class.